Okay, guys. Now things will work fine. I'm really sorry for the delay and all. So hopefully now everything will be fine. Okay. Hmm. Yeah. Sorry, guys. There are some issues which I ran into because of using it after a very long time. So due to that, some issues were there. Now you guys will be able to use it. Just give me 1 second, okay? Yeah, who's Jay? Why is he writing these rubbish things? Do you understand, guys? It's class going on. We should be a bit serious. Okay, now you won't be able to write anything. Cool. Let me just clear it everything. Okay, let me just take a 1 second. Hmm. Okay, so shall we start now? Okay, so back on track. Just open Jamboard quickly. Yeah, it's already open. Let me just close the list of the students. Let me just see who all writing. Okay, so now you guys already know what is array. You know the basics of the array, how it is stored and everything, right? Now we'll come back and we'll see what is linked list, and then we'll see the difference between linked list and array list, right? Or we can say what is difference between simply array and linked list. Okay, so linked list, what happens now? Linked list is something which will store two things. So it will not just store the value, okay? It will store the value, okay? And it will store the address of next node, okay? Next node, what do you mean by next node? So linked list have nodes, okay? What does array had? Array had elements, right? So array had elements, right? Element at 1 index, element at 2 index, element at 3 index. But linked list have nodes. Node, okay? I'll write here node, okay? This is what linked list has, okay? Now you might be thinking, na, ki, what is this node? So node is look like this, okay? It look like this. It has two parts. The first part is a data part, and the second part is a address part, okay? Which store the address of next node. So do you understand one thing? Linked list contains nodes. It does not contain elements. It contains nodes, okay? And node have two parts. First part is data part, which contains, which we can say, which contains element or the data, right? So in array we have only this data part, which does not have this part, right, in each element. But in linked list we have this data part which store the data, and then we have our next part, or we can keep it as an address part. So this part will store the address of next node, okay? So let's say in our memory, when we create a memory, I'll show you. Let's say we have this memory like this, okay? Mm, mhm. Just 1 second, guys. So in array, you know, no, in array elements will be stored one after the other, right? If one element is stored here, next will be here, and next will be here, right? But in linked list, it is not like that. So one element can be here, second element can be here. Let's say here it is the next element. Next element can be here. Okay. After that, after 10, the next element can be here. Let's say it is 12. After that, it can be here. Let's say it is 9. Okay, it needs not to be continuous. Okay, and so how will we know? In array we knew, right? In array, using the array variable name, we can actually get to the place of the variable, right, where it is. By adding the index number, we can get to the element, right? Let's say we want to access the fifth element of the array. We will just add 5 to the variable name. We will reach to the fifth element. But here it is not like that. So linked list will not have the element in continuous form. Then the question arises, how will we reach to the elements of the linked list? How will we reach? Okay, I'll tell you. Let's say the address of this location is 5. Okay. Right here 5. Okay. Now it will be 6, it will be 7, it will be 8, it will be 9, right? So the location of this is 9. It is 10, then it is 11, 12, it will be 13, right? I'm just talking the location, memory location. Okay, it will be 14, then 15, then 16. Okay, then 17, 18, 19, 20, 21. Okay, now you just be focused here. You'll understand what is linked list. It's very easy. So this location is 22. Now, what I told you, the first the first node, the first element of our linked list is 5, right? Sorry, 1, right? So the first node, as we know in linked list, we have nodes, not elements. So we know the first node will contain 1. Cool, cool. It will be stored at which location? It is stored at fifth location, right? Here it is stored. So this 1 is stored here, and what is the location of this one? It is 5, right? So we'll write here 5. So the location of this one is 5. It is clear? Any doubt here? Our first element is 1, which is stored here at fifth location. Our next element is what? Our next element was 3, right? Do you understand? Do you remember? Our next element is 3. How will we reach at 3? This is the question, right? How will we know what is the next element? We know next element is 3 by seeing the diagram, but how will we tell the computer what is the address of next memory location? So we will store the next memory location address in our next pointer. This is our first node. The second node will contain 3, right? And the address of this node is 13. We know, right? 13. So this 13 we will also store here in the address part of our first node. Okay, got it? So this address part, this node, this first node, which is having 1 value, knows the address of the next node. Okay, this is clear. How will we reach to next part? Cool. Now the next after this 3, the what is the next node? Next node contains 10, right? So how will we reach to next node then? So our next node will contain 10. Okay, so the address of this 10 is 21. This 21 will be stored here as well. So this 3, this second node will knows the address of the third node. Okay, similarly the third node will have the address of the next node. Okay, so now you might be wondering what will be the last node address. The last node next pointer, the last node address, this part of last node will contain what? Because after last node there is no other node, right? So how will we know what the last node will contain? So after 10 will store the address of 9, right? So I think after 10 it was 12. So 10 will store the address of 12. Very bad, yeah. Why it is not working properly? Okay, this is 12. So address of 12 is 9. So 9 will be stored here at 10. So let me just close it. Okay, after 12, the next location, the next value is 9. The address of this is 16. So 16 will be stored here, right? After 9, there is no other location, right? So this will store null. That means this is our first node. The first node tells us what is the second node. So second node is stored at 13 memory location. At 13, we have 3. So we'll directly go there at 13. At 13, we have 3, right? Got it? So our second node has the value 3. And what is the third node? We'll get through this address. So what is this address? 21, right? So we know the third location is at 21 location. So we'll reach here at 21. So at 21, we know the value of third node is 10. And what is the address of next node? How will we reach to next node? We will use this pointer. Okay, this is 9, right? So we'll go here 9. So we'll go from this point, we'll go here. Now this is the fourth node. So what is the value which fourth node has? Anyone can tell? 12, right? So fourth node will have 12. And we know what is the location of fifth node. So fifth node, the location is 10 stored here, right? So using this, we'll go here. This is the fifth node here, right? This is the fifth node, which has 9. That's it. It's an easy thing, right? So now what is the next location of 9? After 9, there is no node, right? It is the last node of our linked list. That is why it is having null here. Okay, got it? That is why it's having null. Null means it is the last node. It is the last node. We don't have any other node after this. Okay. So don't worry. It's a very easy thing. You just have to understand the things. You'll love it. Cool. Should we create a linked list in our memory? Should we code it and create it? Because drawing things, I'm very good at drawing and I'm very good at teaching like this. But today my pen is not working. I think there is some issue with the pen. So that's why you guys have to face some issues, some font issues. Okay. But I'll tell you slowly. Why it is not in order? Suraj is asking. Okay, Suraj. So can you elaborate your question? What is not in order? How? Okay. So the address, someone asked a very good question. How will we know the address of the first element, right? Or we can call it, because we need this first node address, right? This node address where it will be stored. If we know the first node address, we can get to each node, right? One by one, we can read reach to every node of the linked list. But how will we get the first node address? This is a very good question. Anyone can tell me? Misbah is saying head. Good, Misbah. Any more explanation so that everyone can understand? Okay, so we'll keep track. We'll always keep track of the first memory location. The first node address, we'll always store it in a variable. We can name it root, we can name it head. Okay, so whenever we add a node at the beginning, we will always change that location to head. So we'll keep a variable as head. Okay, and in this head variable, we'll always store the address of the first node. Okay, got it? Is it clear? We'll take one variable, and in that variable we will always store the location of first node. Okay, I'll quickly show some things you'll enjoy a lot, and then I'll come back here. Okay. Yeah, I'll explain code, no worries. That way you'll understand more, no worries. Okay. See, these things I have taught before, so I love teaching. But today, I know you might be thinking, yeah, things are not in order, but don't worry. And we'll understand more. Yeah, we'll code here. Okay, it looks fine now. It's our main function. Okay, so anyone have any doubt in this? What is this? What is that? Like, this is a main class and this is the main function, right? Our execution starts on the main function always. Okay, so our execution will start from the main function. Cool. Good. Cool. So what we are doing here, first of all, we know we have to create a node. To create a linked list, we have to create a node, right? So what was the structure of a node? You guys remember, right? So node contains two parts, a data part and a pointer part, right? Which will contain the address of next node. So quickly we will make a class. Whenever you have to make a structure like this now, where you will contain more than one variable, you should always use class. So we'll make a class, we'll name it as node. Okay. So what we'll do here, we'll have a data part. And what part we have? will have a address part, which will have the address of next node, right? So if we want to store the address of next node, so we'll have to make a node part, right? So we can keep it next. Okay, so this part will tell you the data of this node, and this part will tell the address of next node. Cool. Any doubt here, guys? No doubt, right? Cool, good. Now we'll have to make a constructor. You guys might already know about constructor, right? Why do we need constructor? Because whenever we create a node, we have to initialize it, right? So how will we initialize? So what we are planning now, whenever we create a new node, we will initialize it with what we call it. Yeah. So we'll initialize it with the value which will pass. The data part will have the value, whatever will pass. And the next part will have null pointer, okay? Always. It will have null. Cool. These 2 points are clear. Yeah, node is a class. Okay, so in the constructor, what we do, we put the initialization thing, right? Whatever data we send here. So this dot data will have data, and next will have null. So by default, the next pointer, the next part of your node will contain a null. Okay, but we'll change it later. Till now, is it clear? Till now, is it clear up to here? Null is something that tells it is the end of your node. This is your last node. After this, we don't have any other node. Okay, so that is the thing. Now, so node is a class, right? So what this variable, someone is asking, why do we take node as a data type, right? I'll tell you why we took node as a data type. So what do you think this variable will store? This variable will store the address of next node, right? So in Java, everything is about references, reference only, okay? In Java, we don't have anything else. We just have references here, okay? So whatever variable is there now, whatever variable is there, that will only have the difference, okay? No, above, we don't need to create as a public instructor. Okay, we'll use it. We are in the same class, same package. Okay, don't worry about that. Next is basically a variable which will store the address of next node. Okay, cool. Node next. Okay, you guys are confused. I know you did you guys took the oops class? Yeah. So this is what? This is the variable name and this is the data type. So this variable will store what? Will store the address of next node, right? And next node is what? Next node is a node, right? That is why we wrote here node. Cool. The next node will be a node only. Okay. This is clear. Yeah. So the next node will be a node only, right? So that's why we took, we took the data type as a node. Because what is this variable? This is a data variable. The name of this variable is data, and the data type is int. This will store what? This will store integer. What this will store? This will store a node. That's why we took a node data type. Clear? It will store a node, right? It will store the address of next node. That's why we took it as node data type. We can take any data type in Java. Okay, it's up to us. Data type, do you understand what is data type? Data types are primitive and non-primitive. Okay, this is a non-primitive data type which we have created. Java have not created this node data type which we have created. Okay, got my point? Primitive data types are int, int ho gaya, char ho gaya. Okay, these all are boolean. These all are primitive data types. But data type we can also create. Okay, so this is what we are creating. This is a non-primitive data type. Yeah, I understand. So that's why I'm telling from the basics, so that non-IT people can also understand. So now you understand we can make any data type. So now you got to learn a new thing. Key, it's not like we can only make an integer or boolean data type. We can make a data type of our own. So this variable will store the address of next node. So we wanted to store the address of next node. So we wanted to store the address of next node, which is a node, right? That's why we took a node data type. Clear, guys? Should we move forward? Cool. Now we'll try to create our first node. Okay, so what do you understand? How do we create our first node? What is the structure to create an object? If you want to make this structure, if you want to use this structure, we'll have to make the object of this class, right? Then only we can use it. So what is the syntax to make an object of a class in Java? I just need a generic data type, generic name. So class name, then object name is equal to new, then class name, right? Cool. Very good. Who wrote this one? S. Yeah, Vibhuti. Good, Vibhuti. Very nice. So this is our class name, right? We want to create a object of node class. This is our class name. What object name you want? Let's say you want to keep it as first node. Okay, this is our object name. Cool. First node is our object name. Now we'll have to write new. This new keyword will be fixed when we are creating an object. This is class name, then object name is equal to new, then again class name. What is our class name? Node, right? Then are we passing something in our constructor? Yes, we are passing something, right? So we can pass here, let's say we pass here 10. So what do you understand this line will do? Can anyone tell me what this line will do? This line will do something like this, okay? I'll tell you what this will do. This will make one structure like this, okay? And it will store 10 here in the data part, and it will store null here in the address part. So you might be considering we are not storing anything. So where are we storing this 10 and where are we storing this null? So we are doing that in our constructor part. So when we make the object, constructor will call automatically, will get called automatically. We are passing 10 here, right? So 10 will go in the data part. So do you understand what this data means, right? Everyone knows about it. Yeah. So this data, SQL data will do what? So this 10 will be stored inside this data part, right? So we have 10 here inside our data part. Now the next part is we are initializing next is equal to null, right? Next is null. That is why the next pointer is having null. Okay, so this is what we have created. And what is the name of this? Name of this is first node. Clear, guys, up to here? Do you understand this? What this line does? Now, as I told you, whenever we create a new node, we need to keep the address of first node. Okay, so this is our first node, right? So we need to create an address, we need to store the address. So if we need to store the address of this first node, so this first node is a node type, right? The data type of this is node. So if we want to store the address of a node type, we'll again have to create a node type data type variable, right? So we'll again create a node. Let's say we'll name it head. So head will always store the first node address. This is our first node, so head will be equal to. Okay, any doubt here, guys? Okay, cool. Our first node is always like head, and it is pointing there. Now we want to add one more node. After this, we want to add one more node here. Let's say we want to, I'll just tell you what we wanted to do, and we'll do that. Just give me a second. Okay, so we want to add one more node. We want to give here value as 5, and the address of this node will be stored here, right? On the first node. Then only it will point to this node, right? Clear? We want to do this thing, and we'll store here null. This will be our second node. So what we'll do, we'll just code it here like this. So we'll again create okay, so let's say we are putting here 5. So what we have done, we have created this node, right? But we have to keep the address of this node inside this one. That we have not done, right? Up to here, we have not stored the address of this second node inside this first node. So we will do it in the next line. So what we'll do first node dot next will be equal to second node. Okay, clear? This line will store the address of second node in the first node connects. Clear, guys? So what we have done up to right now, we have made two nodes. We have the first node will contain the address of second node, and second node will contain null. And the first node has been pointed by a head variable. Okay, a head variable is there, which is pointing to the first node. Okay, now going back, let's check it. Let's check it. Okay, let's try to see. System.out .println first node का data part is equal to what? What should be the data part? Let's just print it. First node dot data. What do you think it will print? So first node data will print the first node, which is this dot data is 10, right? It should be 10. Clear? Let's run it and let's see if we run it. It's 10, right? First dot data is 10, right? Now this is clear. Head is pointing to which node? It is pointing to the first node only, right? So head dot data should also give 10. Do you agree with me? If we write head dot data, it should also give 10, right? Okay. So let's confirm it once. Let's see if it is working or not. So head data will be equal to head dot data, right? Let's say if it is giving 10 or not. It is also giving 10, right? That means head is pointing to first node. Okay. This is up to here. Everything is working fine. Now, what is the address of second node? If we print like this, second node, leave address, just tell me what should be the second data should be. What it should be. It should be 5, right? Second node have 5. Data part is 5. Let's run it and let's see what it is. What we did here. Second, first full name we have tried. Okay, not just a short form we'll run here. We have tried a full name. Now let's run it. So we have second data as 5. Okay, clear, guys? Up to here, everything is fine. You guys are following. So we have printed the first node. We have printed the second node, right? Up to it is clear. Tushar is asking some doubt for storing address of the first node variable can be other than 2. We can name it any variable name. Head is something which is more meaningful name. It seems a very meaningful name that it is pointing to the head of the linked list. That's why we name it as head. We can name it anything, first node, or we can keep it as root node, anything you want. Okay. Now, Anand has asked a good question. What will be the node dot next? First node dot next. Okay. So according to our knowledge, first node dot next should be equal to the address of this node. Address of this node is this one, right? Right here. This should be equal to the first node dot next, right, guys? Should we check it? Should we check it, guys? The address of this node is equal to the first node dot next or not? So we have to just print it. Just print it. Address of first node is first node dot next, right? Similarly, second node address part. This is the address part of first node, and this is the address of second node. Okay. So address second node will be what? We just have to print the cool. So this two lines should print the same thing, right, guys? You understand that? Address part of first node should contain the address of second node, right? And this will print the second node. So now you can also see if we print a variable now, if we print the node variable, it will just print the address. So it seems it shows key the every variable in Java just store the reference. It does not have any value. If you run it, see it. Can you see both addresses are exactly same? Can you see first node ka next part is sent to the second node address? Clear, guys? Now do you understand that? So I believe in going slowly. Thanks, Kamar. Thanks a lot. I believe in going slowly. I don't want to go fast, but I want to make yourself comfortable and understand these all are very basic topics. Okay. So you should, if no, these all are very tough topics if you don't understand the basics. But if you understand the basic, it is the most easy topic. So that's why I want to go slow in the beginning. Once you understand it, you can go fast if you want. Okay. Sorry. Everyone knows, is everyone is speaking Hindi? Anyone who don't understand Hindi? I don't understand who said. So yeah, there is some people who don't understand Hindi, so I'll have to speak in English only. Thanks for telling Rhythm. Yeah, Vamsi, no worries. I'll speak in English only. I'll tell Kambar, no worries. Okay, I'll tell. First, we'll understand what is linked list. We'll solve some questions, and then we'll go to double linked list. Okay, we don't have to jump there right now. Line number 4, someone is asking. This is just a variable. Okay, like we log, like what, like normally we did int data, int a, int b. We declare a variable, right, which will store a integer. Here we are declaring a variable which will store the node. Okay. So it will store the node. That's it. So we're just declaring a variable which will store the node. Clear? 11 and 12 are just, we are printing something. That's all. Okay. So what do you think? What will store? What will be printed by the second node address part? Anyone have any idea what should be printed by the second? Second node dot next part will print what? Anyone have any idea? It should print null, right? It's the last node. You see, it is printing null. Clear, everyone? Yeah. So how you have created a non-perimeter type, it's not covered in your class. Please elaborate. Okay, you don't have to go into depth to non-primitive data type. We just have to create a class. Okay, when we have a class now, we can use it as a data type. You just remember this. Whenever we have a class, we can use it as a data type, and it will be a non-primitive data type. Cool. Yeah, Vivek, we can do anything you want, but you just understand the right way to do this. Okay, you can try and play around. We can use this or not. Okay, those things we'll cover later. So now we have some agenda. We have to fix that. If you have some other questions related to linked list, you can ask. So Arin is asking, can head point to second node? If we point to second node, then first node address will be lost, right? Because using first node, we can get the address of second node, but using this node, we cannot get the address of this node, right? Can we get the address of first node using second node? No, right? From first node, we can come to second node. But from second node, we can't go to first node. That's why we'll always have the address of the first node, the beginning node. Okay. Do you want to add one more node here at the, after second? Okay, let's add one more node. Okay, I'll just clear something. So what we have up to here? We have one node, we have two node, and we want to add one more node here. Okay. Okay, so let's say address of this is 5. This is, let's say it is 15 address. Let's say the address of this is 9. Value here is stored is 10. Sorry. So value here stored is 10. The next part will contain the address of next node, which is 15. So value here stored is 5. The next part will, it is containing null right now, but we'll change it to 9 and we'll store some value in 9 and we'll store here null, right? So now we'll do that. First of all, we'll create this node and then we'll store the address of this node inside the next pointer of the second node. Okay. Now, no. And one more thing, guys, people are asking me in personal chat, do we have to create one by one like this node? No, we'll make a function that will automatically do these things for us. So don't worry about that. We'll slowly understand the things. We'll slowly understand. I'm just teaching you to understand how linked list works. Okay. Once we know, we'll easily do it using a function. It will automatically add a new node to the end of the linked list every time. Don't worry about that. Okay. Good question, by the way. Okay, so now we have first node, head is pointing to first node. Now we have second node, first node connects is pointing to second node. Now we are planning to create a third node. So how will you create it? A very simple thing. Again, you have to follow the class name, then object name is equal to new class name. So node new node. Let's go to new node. What value you want to? Let's say you want to put here. Let's say we are putting 20 here. Okay, let's go with Sneha. Okay, so we have created another node here, right? So right now we have created one node here. The value is 20. This is we have done, but we have linked these two nodes, but we have not linked these two nodes yet, right? Because this 9 is not stored here. Agree with me, guys? Now let's do that. So what do we do here? Second node dot next will be equal to third node. Clear, guys? Is it clear, everyone? So what have we done here with this? Just 1 second. Okay. So with this, we have created a third node. The second node dot next will contain the third node address. Okay, so now we have linked that. So what is the second node connects? This is second node connects. It will contain the third node. So third node address is 9. So it will store here 9. Okay, and here it will be null automatically when we create this node. So this is also linked. So we have 3 nodes. Okay, you want to try? You want to check it? Let's say we are printing. Okay, let's say head data is what? First node data will be equal to head dot data, right? So if you want to print the data of first node, we can we can print head dot data. It will print the first node, right? It will print 10. If we go and see here, it will print 10. I'll just show you how we can use the first node, this head, to print all the 3 node values. So what do you understand? What do you think second node can be printed? Second node. Can we use head to print the second node? Can we use this head? Head is pointing where? Head is pointing here, right? Can we use this head to print the address of this node, value of this node? Yes, right? Head dot next will be what? This is head. Head is storing this node, right? This address of this node, which is 5. But head dot next is storing 15, which is the address of next node, right? So head dot next means we are talking about this node. Clear? So head dot next will be when we write head dot next, that means we are talking about this node, this whole node. So if we write head dot next dot data, data. So don't you feel it will print 5? It will print the data of this thing. Okay, because head is this, head next is this one, this node, and then data wala. So it will print data. Let's see what it prints. So if you want to print the data of next node, we can just use head dot next dot data. Okay, it will print the 5. Can you see? We got the data of second node without even using second node. We are just running through head. Okay, can you see using the first node how we can iterate over all the nodes? Okay. Yeah, we can print 20, 30, 100 using head. Okay, it's up to us. But we don't do this normally. I'm just showing you just to make you understand how this works. Third node data will be how? What do you see? Yeah, Nikhil. So head is this one. Head dot next will be this. Okay, this is head dot next. Head dot next, which is this one. The head dot next ka next, which is this one. Head ka next is this, and iska next is this one. So this is stored in the address of next node. So head dot next means we are talking about this node, right? Now head dot next we're talking about this node. Dot data will be 20. Okay, so we had to use next 2 times. Head dot next. I think you guys are enjoying it. Dot next dot data will print the address of the value of third part. Okay, can you see? Using head, we are actually running through and we can do this. Okay. So now, what is the benefit of this linked list now? Let me know that first of all. Now we know what is linked list. Now let's come back and let's see what is the difference between array and linked list, why we are using it. Okay, first of all, the main difference here is, let's say we had some memory like this. Okay, okay, let's say we had some array. So array will always be stored in continuous memory location. Let's say this was occupied by some array. Okay, let's say we have a memory in our computer which have only this many memory. We don't have any other memory other than this. So let's say this part is occupied by some array. Okay, this part is occupied by some array. Let's say this part is also occupied by another array, right? Because array will be always stored in continuous memory locations. Let's say this is occupied by some other array. Similarly, this is occupied by some other array. Okay, clear? Now, let's say we want to store. Similarly, let's say this is last one is also occupied by some other array, right? Because array can only be stored in continuous memory location. Let's say we want to store 1, 2, 3, 4, 5, 6, 7. Let's say we want to create an array of 6 elements. Can we create here in this memory? Because we have only 2 memory remaining here, 2 here, 1 here, and 2 here, right? Let's say we want to create an array of 6 values, 6 elements. We can't do it, right? Because there is not enough memory. But using linked list, we can do it. How? Our one node will be stored here, second node will be stored here, third node will be stored here, fourth node will be stored here, fifth here, sixth here, seventh here, eighth here. We can do 8 at least, right? Got it? So we don't have to create, we don't have to store in continuous memory locations. Linked list nodes can be stored anywhere. We just be storing the address of next node in the first node, and then the address of third node in the second node. Like this, we know where all those elements. Okay, now in array, we knew if we have this array, right? So these all are the elements. If you want to store one element here, this element will be shifted to the right side one by one. So it will take order of n time, right? To shift the elements, if you want to insert an element in array, right? Similarly, if you want to add it to the end, it will take order of 1 time because we just have to go to the end. If you want to add in the beginning, it will again take order of n time because all the elements will get shifted to the right side one by one, and then we'll add it in the beginning, right? But in linked list, let's say we had this node, we wanted to add another node in the beginning. Will it take order of n time? We'll have to shift these elements? No, right? We just have to add a node in the beginning and we'll make this as head. Okay, this was head, previous head, but now this will be our head, this node, and the address of this node will contain this node. The address of this node will be stored inside this new net. Okay, so we just have to add this node in the beginning and we just have to change the head pointer and this pointer. 2 pointer will change. It will be added in the beginning of a linked list. Okay, clear? So it will just take order of 1 time to insert an element in the beginning of a linked list. Unlike array, it will take order of n time in array. Now, someone asked me deleting a node. Okay, so what do you think? How much time it will take to delete a node? It depends on the position. If you are deleting the first node, it will take order of 1 time. Yes, Namrata, it depends where it is. Good, Aryan. Okay. Yeah. If it is at the first location, it will take order of 1 time. If it is somewhere in the middle, we'll have to traverse there. Okay. So it will take order of n time to go there and delete. Now, should we make a function? What that function will do now, I'll tell you. This function will do now. It will create a node and it will add that node to the last of a linked list. Let's say we have called that function. Let's say we call an insert function. Okay. Insert function that will insert a new node at the end of a linked list. Okay. This is what this function will do. Let's say we call here with 10 values. So it will create a node with value 10. Okay. And we'll make it as head. Let's say we again call this function insert function. Okay, with 20. Now what will do? What it will do? Any idea? This will make another node with 20 value, and it will 10 connects will point to 20. Okay, the address of 20 will be stored inside 10. Okay, yeah, at the end. Always it will store at the end. Let's say we again call this function 30. So it will make another node with value 30, and it will the address of this node will be stored inside this 20. Okay, so we'll do one by one like this. We don't have to worry about anything else. Okay, we don't have to do lots of those stuffs, like creating one node and then adding that node, those pointers. We just have to write this function one. This will be a generic function. We just have to pass the value. This 10 we have to pass. It will do it for us. Okay, should I do it for you, or you want to do it by yourself? Anyone wants to try this? Okay, want to try? Let me think if you guys. Okay, I'll do this one. Next one, you guys can try. Okay. Okay, let's remove everything. Okay. So initially your head will point to null, right? That means if your head is equal to null, that means you don't have a link. You don't have any linked list in your. You don't have any node in your linked list, right? Your linked list is empty. Do you understand this point? All of you. When your head is equal to null, that means your linked list is empty. Okay, we'll have to uh, create a new node to add your first node to the linked list. Okay, now let's make our first node. Let's make a function. Okay, what this function will do, we'll have to make a static function because it's inside a main class. It will return the address of head. Okay, so it return type will be node. Okay, why node return type? Because it is returning something. It's not a void function. I'll tell you why it is a node type. Just wait for some time. We'll make a insert. What will pass here? We'll pass here head, and we'll pass here data. So we'll make a new node with this data point, and then we'll add this to the end. Okay, now so what do you think how we can do this? This head, this will use this head pointer, right, to reach to the end of the node. Because let's say we have a linked list like this. Okay, we want to add another node at the end of the linked list. Let's say here we want to add another node. We want to add this node here, right? And we have the address of only this first node, right? Because head contains the address of first node. So we'll have to reach here, right? We have to reach here one by one to the end, and then we can add here, right? Do you understand this point? We just have the address of this first node, but we want to add a new node at the end. So we'll have to use this head to reach one by one to the last node, right? So once we reach the last node, then we can point the last node connects will be equal to the new node, right? Now we'll do that. And we can check one more thing. If your head is null, if your head is equal to null, what does that mean? Anyone have any idea what does that mean? It is the first node, right? It is the first node. Okay, so let's say we create a new node. New node will be equal to new node with value what data part. So with this data, we have created a new node, right? And we want to add this node to the end of the linked list. This is your node. The name of the new node is new node, and we want to add this new node to the end of your linked list. Okay, this point is clear, but we don't know currently, right? How can we do this? So first of all, we'll check if our head is null, that means our linked list is empty. Okay, so once again, yeah, that means our linked list is empty. Okay, okay, you guys are not understanding what's happening here. Someone said it is totally blank. Is it? I thought it's like you guys are enjoying this one. If your head is null, that means your linked list is empty, right? Cool, thank you. Okay, Because your head is null, that means your linked list is empty. That means you don't have any node in your linked list. So when your node will be null? When you have a single node, your head will never be null, right? It will point to the first node. If your head is null, if your head is null, that means you don't have any node in your linked list. You have to add your first node. Okay. That means the node which you're adding right now is your first node. Okay. So I'll show you. When we are adding the first node, we don't have to change anything. We can just return new node. Okay. So this new node which we have created, it will be the first node. Okay. It will be the first node. Got it? Now we can, when we are calling this insert function, we can just add head is equal to insert head, and we can send the data. Let's say we call here 10. So what this will do? Anyone have any idea what this function, when we call this intern function with 10 values, what it will do? It will first of all just go through the function. First of all, we have a main function, and then we have a head which is null. That means there is no node in our linked list. Then we are calling this function. So this is the insert function which we are calling, and whatever this function will be returning, it will be stored inside the head. Okay, so it will always return the address of your head. This function will always return the address of your head. Now we go to the enter function. So we have the address of head here, which is null, right? Can you see this head? This head is null, which we are passing here. That is null. So this is the data which we have to add. Which we have to create a node and add at the end. So now we will first of all create a node with this data. So we have created a new node with this data. Now what we're doing, we're checking if it is null or not. If head is null, what does that mean? That means our linked list is empty. It does not have any node. So this new node will be the first node. Okay. Insert is a function name. Insert is a function name. It's not a keyword. Okay. I thought you understand that. Okay. Insert is a function name. Someone asked, what is the difference between head and first node? Both are same thing here. Okay. Here there is no first node. Here's only head. First node means first node of your linked list. Head will always point to the first node. So both are same thing. Don't worry. Okay. Why we are returning? Because we want to keep track of the head. So our head will be new node, right? So new node address will go inside the head. So now your head will contain the address of new node, which we have just created with this value 10, right? We are passing 10. We have created a new node with 10, and then we are returning that thing. Okay. I think this is not clear, right? Cool. So now we have our first node in our linked list. Okay. And that first node is new node, and our head is having the address of that first node. Now let's say we want to again add that second node. So we'll just call it like this: insert. When again pass head, we'll add, let's say we had a 20. So what it will do? Currently we have what? Currently we have a node with value 10, and head is pointing here. Now we want to add one more node with value 20 at the end, and head connects will point to this node. Okay, so the address of this node will be stored here. Now how we can do this? Any idea, guys? So we'll have to iterate over it. Okay, using head. So can you see in this function, in this insert function, we only have the address of head. That is the address of the first node. So using that first node, we'll have to go to the last node and then add it, right? Class node. Okay, Shubhu was asking, what is class node do, sir? Class node is just a structure which we are creating. So how does our node look? What is this? This is our node, right? It have a data pointer and it has a address thing, right? It has two things. That is what our class node is saying. It will have a data, it will have a address thing. That's it. Okay. Yeah, Kamar, क्या समझ में नहीं आया? Can you tell me more? How can we know that node is having what type of data? Okay, so here we are creating a linked list. Okay, so we know our linked list will have a data and will have a next pointer. So that's why we know it. Okay, you are creating this. You should know what we are doing. Okay, head will only update for the first time when we are creating the first node. That time only head will update. Next time we will not change this head. We will just add a new link, new node at the end, and we'll just like let's say in the first time it will, this address will be stored here. Let's say again we'll add a new node. Let's say with 30 value. Now the address of this new node will be stored here. Okay, like that it will just chaining itself. This head will not change. It will only change for the first time when we are creating the first node. Okay, guys. Hmm. Yeah, I understand. It's a new topic, so that's why I'm being very much patient. You can ask any doubt you want. Address chaining, I'll do it. We have not written the code for that one. I'll do it. So what do you understand by this? How we can do it? So let's say we have the address of this first node. We'll have to go back to the last node, right? Using this address, we'll go back to the last node. Let's say up to here, the nodes are there. And now here we want to create a new node. So first of all, we have to reach here, right? How will we know okay, this is the last node? Because the last node connects will point to null, right? The last node connects will point to null. So the node whose next is null, that means that is the last node, right? So after that node only we have to add a new node. Is it clear? This line is clear. The new node will be added after the node which have the null value. Okay. Okay. We have to add a node at the end of a linked list. And how will we know what is the end of the linked list? The last node of your linked list will contain null. Okay. So we have to use that thing. When the node next is null, that means it is the last node. Okay, guys. Now let's do this. Let's quickly do this. This is our first condition which we have checked. If it is your first node which we are creating, then we will just return from here. But after that, we will not change head. Okay, we'll just use it. So what we'll do, we'll take a temporary variable that will be equal to head, right? So it will point to head. Now we'll go to the last node and we'll add that this newness, let's say this 20, we'll add to the at the last position of your linked list, and then we just have to change the pointer. So what we'll do, while your temp dot next is not equal to null, till then we can move forward. So temp is equal to temp dot next. Okay, so this is what we are doing. We're just iterating over one by one. We are iterating over the linked list. Our node will be move one by one forward till we reach to the last. So once let's say we find this value true, if your temp dot next is equal to null, what does that mean? Anyone? What does that mean? If it is true, that means we are at the last node. Okay, so let's say if we go back here, if you see here, this is our first node, this is our second node, this is our third node, right? So let's say our linked list is having only 3 nodes. This will be head, right? This first node will be head. It will have some address, but this last node will have null, right? So when we reach here, we want to add our new node here, right? So new node will be added after the last node. So once we reach here, how will we know this is the last node? Because it is null. So we see here, if our next temp dot next is equal to null, then it is our last node, right? We'll have to stop here. Okay. Should we do it now? So we have reached the last node. So what we'll do, we'll just do temp dot next is equal to new node. So whatever new node we have created, we just have to add it after temp, because temp is pointing to the last node. Okay. And we just had written head. That's it. That's it. Okay. Now this will add one node at the end always. So let's say we call it with the 30. I'll show you. Don't worry, okay, guys. If you're not understanding anything, don't worry. I'll like do a dry run of this after this in 2 minutes, then you'll understand more. So don't feel like, oh, this is not understanding. It's very tough. No, it's not tough. Okay, it's very easy. It's just that it's a new thing for you and it's completely confusing thing, right? So you'll understand it very quickly. Just hold on for some time. Okay, just be patient. You'll understand it. Let's say we run it. It's finished, right? Working is finished. So it seems ki our working is fine. Let's say you want to make a function that will print a node. Okay, so we'll just quickly do that. Yeah, we don't need temp. We can lose temp. There's no issue. Okay, don't worry. Now we are writing a function which will actually help us to print our nodes. Okay, this function will print our nodes one by one. So what we can do here, we don't need this line here. If it is null, it's actually we don't want this one. It can be void type. If it is null, return from here. That's it. Otherwise, we can point it as head 10 next not put null. Till then, we have to system dot out dot print. It will be 10 dot data, right? It will print the value. 10 less. Okay. System dot out dot println. Just hold on for 2 minutes. Okay, I'll explain everything. Cool. So this will print each and every value of your linked list. So let's say if we call this print function, what do you think? Ideally, what it should print? It should print 10, then 20, then 30, right? Okay, it should print 10, then 20, then 30. Let's see what it's printing. It's printing the things. It is not printing the last element. Why? Let's go on. Let's find out why it is not printing. Let's do a debugging thing. So we are pointing the 10 here. So let's say temp is 10. Okay, so temp.next is not equal to null. Okay. So we have to remove the next pointer. Okay, so temp not equal to null, it will print the things. Okay, can you see that 30 is also printed here? We can add one more space here, which will help us to see it more clearly. So let's say we add one more node here. Let's say we had it like 15. Okay, so now the explanation part starts. So let's just see here. So we have added 4 elements in our linked list, and if we use a print function, we are able to print all the elements of our linked list, right? This is what you can see, right? This is what you can see. Now the expression part will be there. Up to here, just I want to just ask, do you understand what we are doing here? We are adding elements. So this will add node. This will add another node at the end. This will add another node at the end. This 15 will be added to the last. So how can we prove 15 is added to the last? Because if you print list, can you see 15 is coming at the last, right? Up to here, you can see, right? Our functions are doing. How we are doing it, I'll tell you right now. Okay. Now, when we are inserting the values, how we are inserting? First of all, we are checking if your head is null. What does that mean? What does that mean? We are again at the insert part, right? So this insert function, first of all, you should know what is the goal behind making this insert function. This insert function will always add a node at the end of your linked list, right? Cool. So now when we are doing this, this head is equal to null. Anyone can tell me why we are having this line here, this if here, head is equal to null? Why this condition is here? Anyone? Cool. Who wrote this one? Anshita told. Very good. Yes, Vibhuti. If your head is equal to null, that means your linked list is empty. We don't have any node in your linked list. This is your first node. So whatever you have created with this line, you have created a node with this data part, right? And you want to add it to the last of your linked list. But this seems there is no node in your linked list. So this will be your first node, right? So when your linked list is empty, the first node which you will add, that will be your first node, right? It will be the last node also. It will be the first node also, right? So if your head is null, that means this node which we have just created will be the first node of your linked list. Okay, so this part is clear. Anyone have any doubt in this slide? Yeah, actually we are actually handling a corner case here. So in interviews you should be writing these things. That's why I have written here. Okay, this is the corner case. आप लोग को सब handle करना आना चाहिए. Now, अब हम लोग क्या कर रहे हैं? Let's say we have some nodes already. Now we want to add this node at the end of the node, right? At the end of the node. So now what we are doing here? This new node we want to add to the end of your linked list. So end of your linked list will be what? How will we know that the end of your linked list has arrived? So we have to reach the last node of a linked list, right? And how will we know what is the last node of a linked list? The last node will contain the next as the address or as the next pointer, right? The next pointer as the null. The last node's next pointer will point to null. Is it clear? Anyone have any doubt in this? So using that thing, we can reach to the last node. So what we are doing here, temp is pointing to head, right? So temp, let's say this is our last node, we want to add it here. So temp is pointing to head. So temp is pointing to head, okay? Now what we're doing, we are checking here. Is temp dot next not equal to null? So temp का next null है क्या? No, temp का next is not equal to null, right? Temp का next is pointing to this node, right? Right? So this condition is true. Temp का next is not equal to null. It is not equal to null. Then what we do? We are doing it temp is equal to temp dot next, right? So we are moving this temp forward. So in temp, we are storing temp dot next. So temp dot next is what? Temp dot next is this address, right? This address, which is the address of the next node. So temp is equal to temp dot next. So temp will now point to this next node. Clear, guys? Not temp will not point here. It will point to this next node. Clear? Good. Now what we are doing here? Go back here. Again, we are checking, is temp next not equal to null? So is this temp is connects, is it not equal to null? No, it is not equal to null. Why? Because it is pointing to this node and this is not null. This has some address, right? So again, this condition is false. Again, this condition is false. Again, this condition is true. Temp dot next is not equal to null. Still is not equal to null, right, guys? So again, what we do? Again, we do temp is equal to temp dot next. So again, we'll move this forward. So temp is equal to temp dot next. So not temp will reach here. Up to it is clear, guys. Now what do you see? What this time will do? Now this time temp next not equal to null is false. Why? Because temp next is actually equal to null, right? It is equal to null. So this time this condition will be false. So temp next not equal to null will be false. Why? Because it is equal to null. Okay. Now we got it. So now our temp is pointing to the last node, and after this node we have to add our first node. So address of our new node which is created will be stored in this pointer here, temp next, and this will be our new node. So what we did here, our temp is pointing to last node. So last node dot next will be our new node. Okay, clear, guys? Now in this way we have added this node which we have just now created to the last of our linked list. So this part is clear how we are adding one by one to the last. If we add one more node here, let's say if we add one more node here, tell me any node which they want to add. $100. Okay, so let's see, we are adding 100. Can you see this 100 is also in the linked list? When we write print list, it will be 100 will be printed at the last. Why? Because the whatever we are adding, that is added to the last. Okay, got it? Any doubt here? Let's say if we write a print function after this, after adding 30, what do you think? What will happen? So up to here, when after adding these 3 nodes, we had only 3 values, right? But after adding 2 more, we have 5 nodes in our linked list. Okay. Initially, we had only 3 lists when we printed here, but here we had our 5 nodes. Okay. Yeah, I'll share every code, whatever you want, I'll share it. But you guys are understanding now. That is the main thing. Now, in this insert function, anyone have any doubt? I'll give the times to unmute yourself and ask the doubt. But right now, I'm just asking. Anyone have a doubt in this function? Cool. And now this is another function which is just helping us to print the values. So again, it is we are passing the head here. We are using a temp variable because we don't want to lose head, right? Head will always point to the first node only. We will never move head. We can store the head in another variable and we can use that temporary variable to move forward. Okay. Now we are just using this function. While temp is not equal to null, we are printing and we are moving forward till we are at the last node. Okay. That's all. We are just printing one by one. So it's only 10 minutes are remaining. So do you want to take a tour of the Office? Okay, don't worry. Okay, so today's class, I don't know, I think uh, you guys are very fantastic. Guys are very much patientful, so I love the class. Just that my tablet was not working, so I'll just purchase a new tablet today and we'll try to, like, sorry for 4 5 minutes was delayed there due to some technical issues. So yeah, sorry for that, but I'll try to improve next time. And yeah, I love teaching a lot, and you guys are amazing. You guys are so much patientful, and yeah, that's all from my side for today. Let's roam around and let's see what's happening in the office. Just give me 2 seconds. Okay, I'll just share this code with you. So many of you wanted this code, right? This is the main part which you need. Else you have to create by yourself. So like Utkarsh is asking me to join internet school. ACU job from a long time. But I don't have time, but I'll try to join. So, but I love teaching a lot. Right now, due to those things, I'm not able to do. Okay, just 1 second now. So yeah, this is the gallery. I am on 15th floor right now. So the whole building belongs to Amazon, and this is whole building belongs to Amazon. So my office, my people, my team sits on 15th floor. Actually, no, I'm currently on 7th floor. Sorry, it's the 7th floor. It's a coffee shop here. You can have whatever coffee you want. You can sit here. If you want, you can play chess here like this. And yeah, so yeah, things are like this. Amazing. And let's move forward. Okay, let me see the chat box if you guys have anything to say. Yeah, Amazon are a very nice company. And right now, Amazon is paying far more than Google, Microsoft, anyone else in the industry. So Amazon are paying the highest. Okay. Office is very large. So in 1 week, I'm only able to see a small part of the office. Yeah, this is again a gallery, and this is the lift part. Again, these are all the easy places where we can sit and roam around. And we have a cafeteria, a big cafeteria at 2nd floor. There we get anything we want. Let's watch. This is again office. View of outside. Right now you can't see outside because it's night time. If it is the evening, we can watch games there, and we can sit here also, and whatever we want we can take from this machine. Then again we can sit here and talk. We can take coffee from there. That is also a coffee thing. Outside view you want, you can see it's not a very good view. I don't think we'll be able to see. Just like this, I won't be able to see that, I guess. It's raining outside now, so it won't be visible that way. So yeah, that's all from the Amazon right now. I hope some of you will get here soon. Yeah, and we'll meet in the module 3 class and module 4 class. Tomorrow, if I get time, I'll take class tomorrow also. And yeah, so I'll refer some of them, and it's very easy to get interviews right now in Amazon. It's very easy to clear it. We just have to be clear in trees. You can write it somewhere if you want. So if you want to get into Amazon, you need to be clear in trees. Okay, trees, graphs, DP, hash map. So these 4 or 5 topics you have to clear. Otherwise, it's very easy to get into Amazon. Okay. Food is not free. Food is not free. Coffee is free. Vending machine, you can take anything. But for food, we have to pay. LinkedIn ID you want, guys? I'll tell you my LinkedIn ID. Okay. So I'll share the LinkedIn ID. Right now, I'm not able to figure that out because it's my work laptop. I don't want to open LinkedIn in this. Okay, chalo, take care, guys. I hope I was about I was able to tell you the fundamentals of linked list, which you know. Maybe whatever is left, we'll try to get it tomorrow, and I'll try to get some good gadgets tomorrow so that you can understand. I'll just have some coffee while talking to you, and yeah, you can just assume the linked list is a very easy topic if you understand the fundamentals. But if you don't understand the fundamentals now, it will look like the toughest topic. It's only that thing. Okay, so you just have to understand a bit of things in the linked list. If you are clear with the basics now, it is the most easy topic of your data structures. I'll tell you, it's a very interesting topic. You love working on linked lists. And also, I can tell you. Okay. You guys can enjoy, and we'll see some other. Just 1 second. Huh? We'll see tomorrow, same time. And yeah, all the best, guys, huh? For the future, Take care, guys. I'll give my number to you guys after some time when I feel familiar. Right now, I don't want to give, but I'll give after some time when I feel you guys will not misuse it. Okay. So I feel very good right now. You guys are very, very fantastic, very faithful. Okay. Chalo, take care.